I am Dr. Subbalakshmi, having 30 years of experience in teaching chemistry to college students, both in undergraduate and postgraduate levels. In this series of videos, we are going to look at certain topics which will be useful to the higher secondary students. I hope it will be helpful to them to have a strong foundation of chemistry in their school days itself. At first, let us look at chemical classification of matter. Matter can be chemically classified as pure substances and mixtures. Coming to pure substances, they are of two types, elements and compounds. Elements contain only one type of atoms and they can be monatomic or polyatomic. Copper, carbon, silver, gold, sodium, lithium, and calcium are certain examples of monatomic elements and their atomicity is 1. Regarding polyatomic, they contain two or more atoms of the same element per molecule. Hydrogen, nitrogen, oxygen, and halogens are diatomic in nature. Here, X stands for any halogen. Their atomicity is 2. Ozone is of molecular formula O3 and it is triatomic, having the atomicity of 3. Phosphorus and sulfur are polyatomic. Compounds are formed when atoms of two or more elements chemically get bonded in a fixed ratio. For example, when you take water, one molecule of it consists of two atoms of hydrogen and one atom of oxygen. Carbon dioxide is another example. We can add some more examples like sodium chloride, glucose, and naphthalene, copper sulfate are examples of compounds. The properties of these compounds are different from their constituent elements. For example, let us take sodium chloride. It consists of sodium and chlorine. We know the characteristics of sodium. It's a soft, shiny metal, and chlorine is a gas with an irritating odor. Whereas sodium chloride is crystalline in nature and has different characteristics. So also the other examples. The constituent elements of glucose are carbon, hydrogen, and oxygen. None of these have the characteristics of the compound, the sweeter taste. The next classification of matter is mixtures. Mixtures contain more than one chemical entity without any chemical interaction. When you take sugar in water, you get a uniform solution. This is known as a homogeneous mixture. Another example is sodium chloride in water. Whereas when you mix oil with water, you get two different layers. The lower one is water. This is known as a heterogeneous mixture. Sand in water is another example of heterogeneous mixture. Now we pass on to atomic mass. All of you know that atoms have negligible volume and mass. They have their diameter in the range of 10 raised to the power of minus 10 meters and mass in the range of 10 raised to the power of minus 27 kilograms. By this time, you would have understood that it is impossible to isolate one single atom and weigh it. Therefore, the International Union of Pure and Applied Chemistry, known as IUPAC, has fixed C12 atom as the standard and introduced the term unified atomic mass, otherwise known as EIMU, or represented by the symbol U. It is the mass of 1/12 of one C12 atom. The value of 1 AMU is equal to 1.6605 into 10 raised to the power of minus 27 kilograms. Please note the unit. It is expressed in kilograms. Always units are very important. Now let us look at average atomic mass. At this point, I would like to remind you of isotopes. We are going to look at it briefly. Isotopes of the same element have the same atomic number but different atomic mass. That is, the isotopes of the same element have the same number of protons and electrons but they differ in their number of neutrons. Hydrogen exists as three different isotopes: protium of symbol H, deuterium or heavy hydrogen of symbol D, and tritium of symbol T. All of you know that the atomic number of hydrogen is 1. Now stop the video and try to answer this question. How many protons and neutrons are present in each isotope of hydrogen? Answer. The number of protons is the same for all the three isotopes of hydrogen, that is equal to 1. But the number of neutrons in H, D and T are 0, 1 and 2 respectively. Have you got the correct answer? The isotopes of any element exist in certain proportion in nature, which is known as the natural abundance. For example, the most abundant isotope of hydrogen is protium, having the symbol H. Among the isotopes of carbon of atomic number 6, the percentage abundance of C12 isotope is nearly 99. That is, if you take 100 atoms of carbon, 99 of them exist as C12 isotope. Carbon exists in plenty on Earth and C12 is the most abundant and stable isotope of it. Probably that is the reason why C12 is fixed as the standard by IUPAC for atomic mass. Average atomic mass of an element is the weighted average of the atomic masses of all the isotopes of that element, taking the natural abundance of the various isotopes into account. To understand this, let us take chlorine. Chlorine of atomic number 17 exists as two different isotopes, Cl35 and Cl37, of relative abundance 77 and 23% respectively. To calculate the average atomic mass, the atomic mass of each isotope is multiplied by the percentage abundance. This is repeated for all the isotopes of that element. Then the sum is divided by 100. For chlorine, for the first isotope, the product of the mass and the relative abundance is 35 into 77. And for the second isotope, it is 37 into 23. The sum is divided by 100. The answer is 35.46. The unit for the average atomic mass is U. For chlorine, the average atomic mass is closer to 35 since the Cl35 isotope's abundance is approximately 3 times that of Cl37 isotope. Let us do this exercise. Calculate the average molecular masses of the following: A. Potassium permanganate and B. Potassium dichromate. The first step in the calculation is to find out the constituent elements and also the number of atoms of each element present in the molecule. Next, the atomic mass of each element is to be multiplied by the number of atoms present in the molecule. The sum is the answer. Coming to potassium permanganate, it is evident from the molecular formula that one molecule of potassium permanganate contains one atom of potassium, one atom of manganese and 4 atoms of oxygen. Therefore, 1 into the atomic mass of potassium plus 1 into the atomic mass of manganese plus 4 into the atomic mass of oxygen gives the answer 158.04. Therefore, the average molecular mass of potassium permanganate is 158.04 U. Next, question number B. For potassium dichromate, it is evident from the molecular formula that one molecule of it contains 2 atoms of potassium, 2 atoms of chromium and 7 atoms of oxygen. Following the same procedure, we get the answer 294.18. Therefore, the average molecular mass of potassium dichromate is 294.18 U. Relative atomic mass is the ratio of the average atomic mass to the unified atomic mass. If the relative atomic mass of an element is X, that means the mass of one atom of the given element is X times as heavy as 1/12 of an atom of C12 isotope. Relative molecular mass is the sum of the relative atomic masses of the constituent atoms in one molecule. If the relative molecular mass of the given substance is Y, then it means that one molecule of the given substance is Y times as heavy as 1/12 of an atom of C12 isotope. To summarize, matter can be classified into pure substances and mixtures. Pure substances are of two types, elements and compounds. Elements contain only one type of atoms and they can be either monatomic or polyatomic. Compounds are formed when atoms of two or more elements get chemically bonded in a fixed ratio. Mixtures consist of more than one chemical entity without any chemical interaction. They can be either homogeneous or heterogeneous. Atomic mass. Since atoms have negligible size and mass, UPSC, the International Union of Pure and Applied Chemistry, has fixed carbon 12 as the standard and introduced the term unified atomic mass, which is otherwise known as AMU or represented by the symbol U. It is the mass of 1/12 of one atom of C12 isotope and its value is 1.6605 into 10 raised to the power of minus 27 kilograms. Since many elements exist as isotopes, average atomic mass is calculated. Average atomic mass of an element is defined as the average of the atomic masses of all the atoms of it in their naturally occurring isotopes. Relative atomic mass is the ratio of the average atomic mass to the unified atomic mass. Relative molecular mass of a compound is the sum of the relative atomic masses of the constituent atoms in a molecule of it. So in this video, we have covered the above mentioned points. Let us meet in the next video to discuss some more basic concepts of chemistry. Thank you very much.